Hello everyone, welcome back to our final session of Advanced Artificial Intelligence workshop. Today we will be doing natural language processing. Okay, so it is a vast area. It's not supposed to be covered on a single session of 2 hours, but today what we will be doing, we will touch up every aspect of natural language processing, and we will build a model, use all the feature engineering, all the key aspect of natural language processing, and try to make a model which can predict let's say a spam classifier. Okay, this is the basic and most beginner friendly classifier that one can build using natural language processing. We will be using a new library called NLTK. You must have heard of that. On top of that, we will be using scikit-learn and the basic pandas and matplotlib for our data manipulation. Okay, so before jumping into the coding part, let's see what is natural language processing. I won't be dealing with too much of background statistics and mathematics. I will be giving you a very brief introduction how what is machine NLP, how it is being done, what are the applications of NLP, and then we will jump into coding, and through coding we will be discussing different key aspects that is regularly or that is the most adopted process we use in our industry for natural language processing. Okay, so let me just switch my window. Yeah, so natural language processing is like it is done for text input. When my data is text, okay, that is written in a natural language like English or Hindi or Bengali or whatever language, French, Japanese, whatever. Okay, so the input is text, and it can be unstructured also. Most of the cases these are unstructured text data. Either you have done web mining or data mining from different sources to store the text file, or you have a constructive text, a structured text input. In any of these cases, we have text as input, and now we need to do three major tasks. Okay, first off is task 1 is compile the text, compile the documents. Okay, the second task is featureize them, and third, what we will be doing, we will compare those features, compare these features. Okay, so we will first compile our data, then we will do some feature engineering, and then we will be comparing the features. So that is the entire idea of natural language processing. Now previously we were using let's say numerical data or categorical data. That is for normal machine learning input. These are the machine learning input data. For natural language processing, this data is text. Now we have to format that text in a way we can compare those features. As we know, no machine learning takes input as categorical or text or any other format. It only takes numerical inputs. Okay, so we need to transform it in some way. So let me give you an idea how it looks like. Okay, So let me just go to another page. Let's say I have two documents. One document says green apple and one other is says red apple. So these are my two documents. So this is my doc 1, this is my doc 2. Okay, now these two documents I need to feature them. So this is my first part, I collected those documents. In second part, what I will do, I will featureize those documents based on, let's say, for word count. Okay, so I will count the words. How many unique words we have? We have green, we have red, and we have apple. So 3 words. So we can represent this first document, green apple, let's say green apple as 3 distinct words. One is green, one is sorry, all the words, if I just put it into, one is red from the entire docs and one is apple. So we have collected all the possible words, and out of this, if I want to put first document, this is doc 1, so what I will say, this is 1 count of green, 0 count of red, and 1 count of apple is there. So this document can be represented as 1 0 1. Similarly, this is my doc 1, so this is my doc 1 is this. Similarly, doc 2 will be 0 1 1 comma, these are the, so this is the representation of documents 1 and document 2. This representation, this numerical list is called vectors. These are the vectors. That says whatever unique words, that means the vocabulary, this is my vocabulary. So these 3 words are my vocabulary for these and these 2 documents together. If I have, let's say, more documents together, all those document 1 2 3 dot dot n, this entire set of documents, so set, this is set of documents, and this is called corpus. So the term is clear. The total number of documents we have together, it called the corpus, and inside those corpus, all the different words that we have are called vocabulary. All the different words together in a list, this list is called vocabulary. So in this case, I have 2 docs, a corpus of 2 document, and the vocabulary of 3 words, and using this vocabulary I can represent the first document as 101 and second document as 011. Understood? So this is the counting the words. If I have green apple as another document, then it would have been, let's say, doc 3 is green apple. This is my doc 3, let's say. Then doc 3 would have representation of green means 2, red is 0, and apple is 1. This is the doc 3 representation. So we have a clear idea what is vector, what is vocabulary, what is corpus, right? And representation of this kind, this representation using word count is called bag of words. Okay, so we are using bag of words to represent the word count of a doc inside a corpus. Okay, so I guess these terms are clear. So the main terms we used here is corpus, vocabulary, vector, and this bag of words. Okay, okay, cool. Now we can use which is called cosine similarity. So cosine similarity on these vectors, to determine the similarity between two documents. How? Let's say from previous, let's say we have doc 1 and we have doc 2, and these are the vectors. These are two vectors, so we can represent it as vector A. Say doc 1 vector, doc 1 is vector A, doc 2 is vector B. Then the similarity, I can write similarity between A comma B, that is sim AB is equals to cos theta. Okay, and cos theta means it represented as A into B upon magnitude of A and magnitude of B into, right? So what is this A into B? A into B means I have A as what? 1 0 1, this is my A, and 0 1 1, this was the A and B. So every single element will be multiplied, so that is represented as AI into BI, AI into BI for all I equals to 1 to n. So for I equals to 1 here, A is 1, B is 0, plus for I equals to 2, A is 0, B is 1. So it will, and here in downside it is something like square root of this. So square root of AI square for I equals to 1 to n into square root of BI for all B, I equals to 1 to n BI. Sorry, this is not M, this is N. Okay, so this is the similarity. So if I have something like this, let's say this is A, this is B, just an example, this is theta. If theta is big, or I have a large value of theta, that means these two vectors are far apart, these two are not similar. If theta is less and less and less, that means these two are more similar. So as we know, cos 0 is equals to 1 and cos 90 is equals to 0, that we know. So 1 means these two are similar, 100% similarity, A and B, and if this is 90° apart, that means there is no similarity, these are very much different. Okay, so this is the idea of taking the similarity. Okay, I hope this is clear. Now we can improve this bag of word. So this is my bag of word. For A, this is my bag of word. This is my bag of word for B. So we can improve the bag of word by adjusting the word counts on their frequency in corpus. Okay, so in bag of words means in how many times a single word. So word 1, let's say word 1 is apple in our last example. How many times apple appeared in the corpus? So I know apple appeared one single time in document A, single time in document B, but if I calculate in corpus, that means the combination of all the documents, I have apple 2 times, right? So this is the count frequency, and how many documents it appeared? 2 in 2 documents. So out of 2, both documents have the word apple. So this is the frequency of apple in corpus, right? So this is what the frequency of the words in the corpus is called. So this can be calculated using another method. So the other method is TF-IDF. What is TF-IDF? TF means term frequency. Term frequency. What does it mean? It actually means importance of a term. Term mean here a word, importance of a word within the document. So importance of a term within a document, not the corpus, document, single document. Okay, it can be represented as TF D comma T is equals to number of occurrences of term T. It can be represented TF D comma T. That means number of occurrences of term T. Let's say apple here. Number of occurrences of apple in document D. Let's say doc 1. Okay, so TF is apple appeared how many time in document 1, or apple appeared how many time in document 2. This is the TF of apple. Okay, similarly for IDF, that is inverse document frequency. So inverse, let me write it cleaner. Inverse document frequency. What this means? This means the importance of the term in the corpus. So this is importance of the term. This is importance of the term in corpus. Okay, and that is represented as IDF is equals to log of capital D upon T, where capital D is the total number of documents, where capital D is total number of docs, and small t is the number of docs with term X. Number of docs with term T. So let's say for our example, this D is 2. We have 2 number of documents, and T, if I say T is apple, for apple T is also 2, because apple appeared in both the documents. So this is capital D is 2 and small t is also 2. So if I need to calculate IDF, so log 2 by 2 log of 1. Okay, so this is my TF and IDF. Mathematically, now I need to put some weightage given a word is appeared this many times in this document. So this is these two mathematical expression of these two mathematically it is represented as weight of x comma y is equals to tf x comma y into log of capital N upon df of x. So what is this tfxy? So let me just write it down. So this is my weight of a term. Okay, tfxy, that means frequency of x in document y. Okay, what is n? N is the total number of docs, and what is dfx? dfx is number of docs containing x, number of documents containing term x. Okay, so x here is the term. I want to calculate the weight of x, then the weight of x in a given document y is calculated by the weight of frequency of x in that document multiplied by log of total document upon number of document containing x. Okay, so I have to calculate the tf in that document of this word, any word, and then I have to take log of total document upon all the total number of documents where x appeared. Okay, so this is the mathematical formula that is being used. Don't worry, you don't need to formalize this or remember this. It's just for your information how TF-IDF works. All these are built in our library which we will gonna use. Okay, so now we will be using another thing before we start. If you don't know that we will be using NLTK library. So if you don't, it is not default, by default you don't have NLTK library with Python, so you need to do conda install, NLTK, or pip install NLTK. Okay, any one of them you need to do in your console to install this library and work with it. Okay, so whenever you start, if it is not installed, you need to install it. With that, with this this much of theoretical background, I guess we can start. Okay, so this is the TF-IDF I have covered, and then these are the similarity, how to consider similarity, and what are the special terms we have in our natural language processing. Okay, so let me now just switch. If you have any question till now, you can ask, or we can start coding, and then you will get more clearance about it. Okay, I guess there is no such question. So let me just switch my window. Okay, and let me just put myself off so that yeah, perfect. Is it visible, the Jupyter notebook? Okay, coding. Okay, so this is the file I will share with you. Okay, it has all the detailed documents to understand, but now I will walk you through step-by-step coding. So let me just open a new Python file. Yeah, cool. So first of all, we will start by the basic imports, like import pandas as PD, import numpy as np, import matplotlib .pyplot as plt, and import seaborn as SNS. Oh, I guess I typed it wrong. Matplotlib NLTK. Okay, we can do it by NLTK dot download shell. Once we install the NLTK by pip install, you just import it, import NLTK. Okay, and after importing it, you need to download some stuff. Okay, we will be downloading only one thing, that is stop words for our purpose, but there are a lot of stuff comes with NLTK library that you can download. For now, you can see all those stuff, like let's say NLTK dot shell, sorry, download shell, download shell. Okay, so you can pass download, D for download, see the list, you can update, config and quit. Okay, so for this downloader, just let's see what are the list. These are all the packages. You can continue typing enter, 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 enter. So these are all the thing you can download. Out of those, we will download this stop words. Okay, so I will type D. Okay, just now it is finished. I will type D. So it will now ask what you need to download. Then I need to pass what I need to download. Stop words. So I already have the stop words downloaded, so it is showing up to date. But you can go ahead, download, and then you can type Q to quit. Sorry, Q. Okay, so let me just comment it. If you need, you once you done with this, so you have your stop words downloaded. Now let's move on. Okay, so for now we will use UCI repository. Okay, UCI dataset repository. So you can type UCI repository, and the first thing you will come up with is the machine learning repository of UCI. It is provided by University of California. This is a place where you can find data. Okay, so you can view all data sets, and according to your needs there are 557 data sets here, based on what you want to do, classification, regression, what kind of data you need. Okay, based on that you can download the data. So from there I have used the data called spam collection, SMS spam. Okay, so if I just write here SMS spam, maybe, yeah, so this is the data. You can download the data folder from here also, or I will provide you the link to download directly. Anyways, so let's just first create an data set and create a list of those lines. So line dot rstrip for line in. So I will open the data set. The data set name is SMS spam collection. I guess that is the name. Let me just see. Yeah, SMS spam collection. So I will open the data, and for every line in this data I will just do the art strip. Okay, art strip is a method to strip all the lines. Okay, you can go ahead and check what it does. Okay, let's just see the length of the data. So length SMS. So we have 5,574 data sets. Okay, you can type SMS 0 to see the data. So this is a type of data. So this many of different SMS we have. Out of this, some of spam and some are ham. The ham means the ordinary data. Okay, so this entire collection is our corpus now. Okay, so let's see some of the messages. To see those messages, let's let's say message number and SMS in enumerate our SMS, and I want to see the top 10 only from starting to 10. Sorry. For let's just, I forgot to provide the print mess number and SMS, and let's also print a new line so that we can see it correctly. So these are the messages. Okay, so I just counted, because to count that I passed on enumerate. You can go ahead and see what enumerate does. It is a built-in function in Python. So, and then I printed the enumerate number and the SMS also, and these are, this 0th SMS is a ham that says go until jargon point crazy and this stuff. Entire, these are the separate messages. Okay, so as we can see, we have the message body, we have the label name, whether it is a ham or spam, and it is separated by a tab. Okay, so this is the structure of our data. So we can see, we can here see also SMS. If you have seen SMS 0, sorry, this has got SMS. I need to read it once more. Okay, now if I just let me just SMS 0, this is the SMS, and you see it is separated by \t, right? So it is separated by a tab, so we can use it to store in a data frame. So if I want to write, if I want to store it in a data frame, I will call pd.readcsv. So it is a TSV value, tab separated value, but I can use the separator, mention the separator, and store it in a by read CSV method. So SMS, let me just copy the name. SMS, then I pass on the separator, sep equals to tab, and I will name the columns. So names equals to, I will provide the column names, that is first one is label, and second one is the message. Sorry, okay, let's run this and see SMS. So this is my, now this is the data looks like. Okay, so label, message, like that. Now let's see the description of the data. To see that, sms.describe we can pass. So these are the counts, unique values. So 2 unique labels, 5169 unique messages. Okay, the top labels are ham. So ham has ham is higher, number of ham is higher than number of spam. Top a message, the repetitive message is sorry, I will call later. Frequency of ham is 4825, and number of message that has repeated this thing is 30. Okay, so this is the description of the data. Now let's group by the level, how many ham and spam we have and what are the description. So if I just see individual description, we can do group by. Let's say level, and then we can see the describe. I will just add another column called length, and I will call up the message column from our data, and I will apply the length function. Okay, and if I see, sorry, now we have the length. Let's plot it. Let's plot and see what is the distribution of the messages having different length. So we can use that SMS call the column I want to plot. So length, then dot plot dot hist, and we can pass the bin number of bins is equals to, let's say, 100. So this is the distribution, right? These many bins. These are the distribution of the length. So we have a certain spike in the later stage, like having word count of more than 100. We also have a very big spike in like around in 50 words. Okay, so these are the lengths. Sorry, 50 characters and 100 more than 150 characters. We can also see, we have little spikes here and there, right? So if we just make a, let's say, fixed size is equals to 10,8. If I just make it a little bigger, maybe it is easier to see. Yeah, so you see we have here also a big message, more than 900 counts, I guess, right? So let's see what are the description of this SMS length dot describe. You see this length column has a max value of 910, a message containing 910 characters. That is a huge message, right? Average value of messages are 80 characters. Minimum is 2-character message. I don't know what it is, maybe okay or see you or yeah, something like that. Okay, so this is the description. You can see the standard deviation and all that, the statistical description. Okay, we can make a subplot and see also that. Let's just see what is this message, this 910 characters. Okay, to do that, let's type it SMS, and in that I will call SMS length column, and I will see having the number 910, and then that row, from that row I will call the message column, and I will plot it I location 0. I just want to see, this is the message, this is the longest message in this dataset, and it is something related to love. Yeah, for me the love should start with attraction. I should feel that I need her every time, blah 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 blah. Okay, so it is a love letter. Okay, so let's switch to our thing. We can plot and see what are the distribution in different things, like what are the distribution of length in our spam messages and our ham messages. So we can do that. So let's do that. SMS.hist, so histogram, and we can call it by columns. COLUMN. Column is our length. We want to plot the length, and we want to create 2 columns by label. So the number of unique labels we have, the number of subplots we will be having. And let's say bins equals to 60, and let's say fixed size is equals to 10,8. So as you can see, there is the ham has a separate distribution. The more number of messages have less number of words, whereas spam has a different distribution. Most of the spam messages has a word count 150, around 150, and in case of ham, that is a original message, it has a word count around, let's say 50, right? So 50 and 100. So there is a very distinguishable pattern in the length. Okay, so we can use that pattern in our feature engineering. So now we need to convert the text into numerical features. So we have text values, and we will start with writing function that will split the message into words and return a list. Also, we will remove the common words like a, am, I, is, the. These contains least information about the message. Okay, and we will also remove the punctuations. Okay, so before we start with the messages, our data, let's see an example. So let's say text equals to it is a sample, sorry, it is a sample, it has punctuations, period. Okay, now to do that I need to import, let's just run it first. Okay, text, so this is my text. Now I need to remove the punctuations and all. So to do that I need to import string, and I need to call string dot, if I want to see what are the punctuation, string dot punctuation, so these are the punctuation. If my data has these punctuations, I need to, or I want to remove this, right? So how would I do that? So let's take a look. So I will put the clean no punctuation word in T. So T equals to will be, let's do a list comprehension, C, the character for C in text, if C not in string dot punctuation. Let's run it. So what I am doing for C in text, so this is my text. So for C in text, if C not in the string punctuation, so for every character it will see whether it is in punctuation or not. If not, then it will be stored as C, or if it is true, it will be taken not in, and if it is false, then it will not take C as the part of T. Okay, understood? So let's just see what is then T. So this is my T. So it is a sample. You see, you have I had a exclamation here, but it is removed because it is part of the punctuation here, the first one. Okay, so and the last, but that is also removed. So we got rid of the punctuations. Now what I need to do, I need to join these characters to bring back our string. So I can use T equals to empty colon empty brace quote dot join and pass the T. Okay, this will bring back the entire sentence. Okay, if you want to know how this thing work, actually it joins everything in between every character. So if I pass nothing, it will join nothing, and it will join all the thing in the character. So if I made it more confused, if I made you more confused, let's see an example. Let's say x equals to a comma b comma c. Okay, and if I just pass, so let's just say x is this. If I just pass underscore, dot join x, and x equals to, if I just pass this, let's see if it, so it joins this thing within the code after every character or every character of this list. Okay, and if I don't pass anything, it will join every character together. So this is the join function. Okay, so I hope you got it. Now let's split this entire string into its words. So t equals to, so t dot split, if I, sorry, t dot split, if I perform this, I have every word separately. So now I want to use the stop words. I want to remove this is, a, it, has, these are all the stop words. Okay, so let's see after removing stop words how it looks like. So for that, first I need to import those things. So from nltk dot corpus import stop words. Okay, if you want to see what are the stop words, stop, what is going on, stop words dot words, what are the words in English language, what are the English stop words. So these are all the stop words in English language. Okay, so I will pass this stop words and see if my data has these stop words, I will remove them. Okay, so and I will call it a clean text. Clean text is equals to, let's say w for w in t dot split. So I have a list of words. If w dot lower, so I lowercase all the words in the list, not in stop words dot words English, then it will be stored in clean text. So let's run this. Okay, so now we have a clean text and let's just see what this clean text look like. So if I just clean text, so out of the entire text, it is a sample, it has punctuation. We got sample and punctuation words out of the text. This is my clean text after cleaning the texts. Okay, although we can perform other operations like stemming, lemmatization and all other stuff, but it is not needed in today's case, so I am not going into every other thing. So stemming and lemmatization is like run, ran, running. So these all words have same root words, run. So if such thing happens in a text, it will break down all those words into a same word called run. Okay, so that is called stemming. And lemmatization is also jotting down to the same words, but it will use so dictionary. So if you have a past or present or future of some word, it will do the dictionary wise conversion conversion of the words using the grammar. Okay, so lemmatization is the same thing using grammar. Text process SMS, and let's just what are the thing we want to do. So what we want to do, the first one is remove punctuation, remove stop words, and then return list of clean text words. Okay, so this is what my function will do. So let's just do that thing. T equals to the same thing, remove punctuation, what we have done here, the punctuation removal, this. Let me just copy paste it here. In case of text, we will write SMS. Right? So this is one thing. Then we will do T equals to, we need to join those, T dot join those characters. Then we will return, what we will return? We will return this thing, right? So this is my little function. Let's just run it. Our function is run. This entire process, now this entire process of punctuation removal, stop word removal, and getting a clean text is called tokenization. Converting a normal text into a number of tokens. Now we have tokens, and we can use those tokens as our terms, right? So there are lots of ways to normalize and do processing of text data. We have done very basic level of it. Okay, we can use stemming, lemmatization, as I told you, and here we are not using those things because the data we have here, it may have very shorthand, a number of shorthand data, like as you can see here, na, you. So these are already non-existent words that we use in our daily life for SMS purpose, right? So using lemmatization and stemming may not perform good results. Okay, now after the tokenization, we will do vectorization. So we need to do a vectorization. So what is vector? The count how many times does a word occur in each message, right? So first thing we need to do that. Then we need to weight the counts so that the frequent token gets lower weight. So if I say a token called go, token means word. Okay, so word go appears in every other text, so this go has very little value to add into the context. Okay, so this will be having less weight. Okay, but let's say a word called let's say graduation, it may not appear in every text, in every SMS, so it will have a higher value in context with that particular message. So it may lead to differentiate that message from other messages. So if the frequency is less, the weight will be higher. Okay, and then we will be normalizing the vectors to a unit length to abstract the original text length. Okay, so the first thing that we said, count how many times does a word occur in a message, that is called the term frequency, TF. Then we will weight the counts, and so that the frequent token gets lower weight, that is that IDF, inverse document frequency. Then we need to normalize those vectors, that is we will be using L2 norm. Okay, so we will see those. Let me just switch back to my open board thing before we go back to our coding. Okay, so let's say we have n number of messages, SMS, for our Okay, so what we can say, let's say message 1, message 2 dot 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 message n. Okay, I can use this as column. And let's say from all those messages we have words, so we list down those words, all the words. So word 1, word 2 dot dot dot, we have, let's say, m words, word m. Now I want to draw a matrix where I will see word 1 is appeared in how many messages. So let's say it didn't appear in message 1, it appeared in message 2 one time, and likewise it appeared, let's say, 2 times in last message. In word 2 it didn't appear here, didn't appear here, appeared here. Word 3, let's likewise we say we have a word m appeared in message 1 and appeared none of others, likewise. So we will create a matrix. Okay, so this matrix has a lot of zeros. This will have a lot of zeros and few values. So this matrix is called sparse matrix. Sparse matrix. You can go ahead and check in the web what is the properties of sparse matrix, and in those sparse matrix, the columns, these columns formed by corpus. This is my corpus. The entire column is my corpus, and this, the rows, this is my vocabulary. So I will be having vocab in my rows and my documents, corpus documents, as my columns. Okay, clear? So you just remember this. This will help you to understand the next concepts. Okay, so let me just switch back again. Cool. So now we will do the vectorization. For the vectorization, we will import count vectorizer, that is in scikit-learn. So let's call from sklearn dot feature extraction dot text import transformer is equals to count vectorizer and I will pass. I can if you just press shift tab, it will show you all the parameters you can mention in count vectorizer. So input, encoding, and all those stuff, stop words, tokenizer, you can do all those stuff. But instead of that, you can also see there is a thing called analyzer. Where is it? Analyzer. Okay, so in analyzer I will pass my custom function that I have made. This function I will be passing. So let's pass that. So analyzer is equals to text underscore process, and then I will pass fit, and I will fit this count vectorizer onto our data. So what is my data? SMS, and from SMS where I want to apply it? On the message column, right? So let's do that. It may take some time because it will vectorizing depending on your system speed. So let's just sit back and wait for a second. When you see there is an asterisk, that means it is processing, by the way, if you ever wondered how I am getting it, it is under process. Okay. Okay, so it is done. Let's just see what is the length of this. So bow transformer, dot, let's see the vocab. How many unique words do we have? Vocabulary underscore, I just run it. So we have 11,425 different words. Okay, so now that we have the count vectorizer, let's do the next part. What is the next part? The next part is to transfer and calculate the weights of the word, TF, IDF, right? And depending on those weighted average, we will apply a model on it and see what are those similar, whether it is a spam or a ham. So that, okay. Now for that, before applying the thing entirely on this data set, let's just take one particular message and see how it works for an example. So let's see, let's take fourth message of the data set, SMS, message, and the third message. Okay, and let's just print it. Print so this is a message. You done say so early, you see already, then say something like that. Okay, so this is a message. So what I will do, I will use that bag of word transformer. So I have a transformer, the counts and all those thing, transformer vocabulary. Now I will use that transformer and apply it to transform this into a numeric value. Okay, so let's do that. So let's say bag of words for fourth. So bow 4 is equals to, I have the entire dataset vocabulary transformer. Transformer dot transform message 4. Okay, now let's see what this looks like. Print BOW 4. So this is the transformed. So bow 4, the message 4, this message is transformed from the text, the string, into the numerical value. So this in the vocabulary, 4068 vocabulary has 2 number of counts in this particular message. This is what the meaning of this bow 4. Bag of words says this vocabulary, this token or this word from vocabulary appeared 2 times in this message. Similarly, this token, 9554th token in the vocabulary, appeared 2 times in this message. So we can clearly say, see this is say what are you appeared 2 times and say also appeared 2 times. So this may be say. We can also see that. Let's just see one. So bow transformer dot get feature names. We can get the feature name. So these are the features now. Every word is a feature. So get the feature name, and we will pass the index of the feature. So let's say pass this one. Okay. So you see, this is u is the feature. This 4068 feature of the transformer we have, bag of word transformer. Okay. We can see the shape of the matrix. Let's see. Shape of the matrix. Okay, let's just do the matrix for the entire message. So we have made the matrix, the transformer matrix, only for this bow 4. Okay, so this is a one column. Now I want to make the matrix for the entire message. All the columns, I will count all the columns and how many words appear in which column. Okay, so to do that, what I will do, so let's say SMS bag of words is equals to, so bag of word transformer dot transform SMS massage. It may take some time because it is transforming the entire data now, so just be patient. So it is now performing that operation to make those that matrix. I just show you a few minutes back. So the messages are in the column and the rows are the words, and it puts all the words appeared in all the which of those messages, like that. So it is a very big matrix we will have to calculate and convert it into those matrix. It may take some time depending on how fast your computer is. Okay, so it is done. Let's see the shape. So print SMS bag of words dot shape. Let's see what is the shape. So as you can see, 5,572 words are there, unique words, and 11,425 rows columns are there. So these many messages are there and these many unique words are there. So number of words are less, number of messages are more. So lots of repeating words are there. Okay, so now that we have done doing the matrix, now we have the matrix. Let's use the TF-IDF. So now what we have this thing. So we have this thing in matrix. Now I want to use the weight instead of the count, right? So that will be the best way to understand what is the value of a particular word if it is appeared in a message. Okay, if there is a word called is and it appeared in 100 messages, it is not serving no purpose or very least purpose. However, is will be wiped out or filtered out using the stop words, but just for example. So I need to see if a word appeared in a message, what is the weightage of the word. Okay, so to do that I need to calculate TF-IDF, and to do that I need to import it. So from sklearn dot feature extraction dot text import tf idf transformer. Okay, so I've imported the transformer. So let's create an instance. So tf idf trans, let's say, is equals to tf idf transformer. I call this and I fit it to the SMS DOW. So the matrix, I will fit it onto the matrix to get the weight. So I have created the matrix. Now I will transform it into the to its corresponding weight. So it may take some more time. Oh, it is done. It is just transferring the weight. Okay, so we are done with transforming the message. But let's just try on a single message again to see how this looks like. So we have this thing. So let's see if I want to transform this thing into TF IDF, how it looks like. So let's say TF IDF 4 is equals to, that will be equals to TF IDF trans. So we have created the instance. Now I have to fit it. Okay, now, or I have to transform it. Trans dot transform the BOW4, BOW4. So I have this count. Now I will transform those count into the weighted vector. Oh, sorry. Okay, now let's see. As you can see, this thing is transformed into this thing. Okay, so although if you see these are the same indexes, just have separate sorted separately depending on the values. Okay, so it is sorted in the index of the vocabulary in descending order. So these are the weights of these values. So we have transformed it. Like now let's just apply this on the entire vocabulary. Let's check a single word. What is the weight of that particular word? If I want to check the single word, what is the weight? Let's say university, or let's say school, or let's say certificate, or something, anything. So let's try that. TF IDF. Let's try. Now I have the transformer. I will put into any words or any bag of words, and it should give me the weightage of the words in the in this corpus. Okay, so this weightage is for the corpus of the SMS data we have. So in SMS data, so trans dot IDF, if I want to see, I will pass the IDF, and I will pick from the bag of words transformer dot vocabulary. Let's say hopefully I have a word called school. If I just run that, the school. So what I am doing, I am performing the inverse document frequency. So I want to see what is the weightage of the word school, but I cannot pass directly school in to calculate IDF. So I need to say from the bag of word transformer vocabulary, take the word school and see what is the IDF inverse document frequency. Okay, so and it is giving 6. If I just change it to, let's say, university, it has a higher weightage. If I say certificate, if at all it is there, it has even higher weightage, 8.93. So this is how you can check the vocabulary words. These words are present in vocabulary and these are the weightage. Okay, if you say universe, universe is not there, so it is showing an error. Okay, if you say let's say cricket, cricket has it and it has this much of weightage. Okay, so likewise, so you can see any word and its value or weightage in that particular corpus. Okay, now let's convert the entire bag of words. So I am seeing every little every single now I have shown two different ways. I have shown one particular string and their corresponding weightage of words, and now then I have shown you the particular, if you want to see particular word and its weightage in that corpus, you can do that also. Now let's just convert entire bag of words into its corresponding TF-IDF weightage. Okay, so to do that, so let's say SMS TF-IDF is equals to TF-IDF trans dot transformer transform and let's pass the SMS bag of words. Now using this we can build a classifier also. Okay, so to do that, classification has the very basic step. First, split the entire data set. Okay, so to split that, what we need to do, we need to, let's say, split it in test and train. Oh, first of all we need to import. Just a second. From scikit-learn, sklearn dot model selection import train test split. So I've imported it. Then let's just split the entire data set. So message train comma message test comma label train label test is equals to train test split. Then I will pass the message column from my data set, and for the y I will pass label column of my data set, and then I will pass test size is equals to 0.3, and then I will run it. What happened? What is the error? Oh, I forgot to mention. Yeah. So test size is equal to 0.3. Okay, so my data is splitted. Now what I can do, I can repeat all these steps. Like first we do the splitting, then do the tokenization, then do the vectorization, then do the TF-IDF, and then pass it into a model. So that is one way. Other way is I can build a pipeline. Okay, so this is a common steps. As these are the common steps, we don't have to do it manually. We just build a pipeline and pass our raw data, and using that pipeline instruction the raw data will be processed. Okay, so we don't need to manually do it all the time. Okay, so how can we do that? Let's see that. So that is pipeline is equals to, for that first we need to import just a second. I guess the pipeline is in from sklearn let me just I just forgot where it is. Pipeline. Scikit-learn.pipeline. Yeah, right. Scikit-learn.pipeline, import pipeline. Okay, so let's create an instant pipeline and see how it is done. Pipeline is equals to the pipeline instant, and we will pass some parameters. So the parameter is the name of the parameter and what is the function. So first function will be the count vectorizer. So that will create the bag of words. So bag of words, and we will pass the count vectorizer, and in count vectorizer we just pass the analyzer as our, so analyzer as our custom function text process. Okay, then what we need to do, we need to do the tf-idf. So we will pass tf-idf. You can write anything here, that is for just understanding what next pipeline task you are doing. The first we are doing a count vectorizer, then we are doing tf-idf transformer. So tf-idf transformer, then we will be classifying. So classifier, and here we can pass any classifier. Okay, so let's just import some classifier. So let's for text document, knife bias is one of the most adopted classifier that gives good results. So let's see how it performs here. So from sklearn dot knife bias, import multinomial NB. So multinomial NB, binomial NB, those are the types of knife bias algorithm. You can go and check how these are how this matters, and I encourage you to check the entire knife bias algorithm, how it works, the conditional probability, how it works, what is the knife bias theorem, and all that. Okay, so do it on your own. I will rather introduce another classifier. Let's say from sklearn dot ensemble, import random forest classifier. So I will use both the classifier. Okay, so first use the multinomial NB, and then we will be using the random forest. Okay, what happened? What is the issue here? Oh, I forgot. Okay. This should be in, these are tuples, okay, so I should pass it in tuples. Okay, so hopefully this syntax error. Multinomial in B. Uh-oh. Yeah. Why it is showing syntax error? Why it is showing syntax error? Analyzer is text process. Okay. Yeah. So I just there was a mismatch of parentheses. So everything, every single process you need to pass it as a tuple. Okay. So the description of the process and the function of the process. Description, function. Description, function. Okay. So now as the pipeline is done, let's just fit it like a normal algorithm fitting that we do in some other language, machine learning, some other machine learning algorithm. So I have got pipeline as my output pipeline. So pipeline dot fit, and I will pass the training. So message train and message test. Sorry, man. Label train. Okay, so it is fitting. It may take a bit longer because it is performing all the operation in sequence, so just have some patience and see what is the output. Okay, so it's done. So it has fitted the model. Let's now predict our test on test data. So let's say pred equals to pipeline dot predict message test. So it has all the predictions here. So now it's time for evaluation. How we do evaluate in a classifier? We do confusion matrix and see the classification accuracy and all those stuff. So for that, let's just import from sklearn dot matrices, import classification report. That will cover everything, I guess. So let's just print classification report. Sorry, classification report of the test and predicted output, the true, that is label underscore test, comma, the pred, and let's just print. As you can see, it is performing quite well. So ham is 90, precision is 96 and 1, accuracy is 96%, so it is doing pretty good job. Okay, so if I just change the classifier, let's see how it reacts. So let's say random. Okay, here, sorry. So if I just say random forest classify. Okay, if I just run the now, okay, let me just import it first. Yeah, it is done. It's fitting on the data. Okay, so it's done feeding. Now let's do the prediction using random forest, and let's see if there is any change in the accuracy or other thing. So let's just wait for the prediction to be done, and it is done. Now let's see. You see, random forest is performing a little better. So it was 96% for naive bias, and now we have accuracy of 97%, right, using random forest. So you can try any number of algorithms here. So this is the industry level of doing or performing a pipeline process using certain operations. So we have done 2-3 operations. So first bag of words, then TF-IDF, then random classifications. It doesn't matter what process you want to do, you just create a pipeline and pass the data in the first entry point, and it will fit and pass through the next and then the next, and it will have the final output through that pipeline. Okay, so this is the exact how in industry the processing is being done using the pipeline. So I guess you have now have a basic idea of natural language processing as well as how to do pipelining using scikit-learn. If you have any doubt, let me see here. I am just waiting now for your doubt clearance, although I know it is a lot to take for one session. So I will provide you all the documents and the resources. You can go through it. It have a very detailed documentation also. So you read it, you go to other resources. Okay, and then you will be very familiar with the concept. Okay, we just scratched the surface of NLP today to give you some motivation how it can be performed, what are the applications. If you have any doubt, you can ask. Uh, I guess there is no such question right now. It would be better if you go through the documentation and resources so that you can understand all the components and how to use natural language processing in a better way. I guess so that we can close it right now. And if you have any question regarding this, you can always ask. I will provide you some practice also, so you can try on your own. Okay, so the practice will be depending on the course we have covered so far, like the some of the models that we have understood, SVM, decision tree, and other machine learning, basic machine learning models. And one, I will be giving you an exercise to make a natural language processing classifier, okay, using NLP, a classifier using NLP. So there you can use any of the model you have learned and you can do all those feature engineering stuff. Okay, I encourage you to go ahead and do stemming and lemmatization also. You find out on your own. This is not a very hard or complex thing to do. Okay, so I encourage you to do that also. If you don't understand, I will provide you the solution also, so you don't worry about that. But I encourage you to practice on those. So there will be two practice thing. One is for SVM, support vector machine, and another is for NLP. Okay, and I expect you to try those things and see if you have learned and remembered and understood all those concepts. Okay, so I guess that would be all for today. And if you have anything to ask, you can go on and ask. Okay, then thank you for attending this workshop. I guess you have got the idea of some of the current advanced topics in machine learning and artificial intelligence, some applications like recommendation system and natural language processing using a classification of text classification using NLP, and some machine learning algorithm, and also with background decision tree, SVM, and KNN. Like these three we have discussed in this workshop, right? So 3 machine learning algorithm, then we built a recommendation system, then today we have done natural classification using natural text classification using natural language processing. So if you haven't gone through the previous, go to PyParadox channel, and there they have the videos of previous sessions. You can see those sessions and have an idea how to build a recommendation system or how to operate with those machine learning algorithms. And thank you for attending. Wish you a very good successful career in data science and machine learning ahead. Peace. Keep coding.